Okay, so my previous approach on this problem was very nicely explained, one step at a time, very sequential, has a couple of drawbacks. One, it takes a lot of separate calculations to work through here, and while everything is nicely explained and laid out and organized, there's just a lot of space on the page. Secondly, it leads to rounding too early, which can cause difficulties with WAMAP accepting the correct answer, because as my very first step here, I've already rounded this conversion factor where I found the circumference. I probably don't want to round at this point. I want to keep pi as part of my answer until I've worked all the way through the very end of the problem and round once I have arrived at my final answer down here. Otherwise, I'm working with rounded numbers through this whole series of calculations. So I got a bicycle here with various parts. I know the radii of all of the different parts, the front gear, the rear wheel, and I have been given the rotational speed of that front gear where the pedals are attached. The cyclist pedals at 190 revolutions per minute. So my question is asking me to find the linear speed of the bicycle, which comes from the rear wheel. That's what touches the ground. So I need to find the linear speed of the rear wheel. So we know from our previous work, we have to follow the speeds through the various parts of the bicycle, converting from one type of speed to the next to keep which speed is the same from one part of the machine to the next. So I'm going to start with rotational speed, 190 revolutions per minute. That is the rotational speed of the front gear. And I haven't actually done anything, but I'll keep track of my final answer over here at the right edge. So the first thing I wanted to do is convert to angular speed, which might seem like an unnecessary step because I don't actually need angular speed for anything. I could have converted straight to linear speed of that front gear. However, this is going to make the rest of my work much simpler if I'm working from angular speed here. So I multiplied by 2 pi radians per 1 revolution. Next, I wanted to find the linear speed of that front gear. So I just need, as a conversion factor, the size of the radius, 6 inches per radius. So this is giving me the linear speed of the front gear. And here's my final answer over here to the right. Now that linear speed of the front gear is conserved and passed on to the rear gear as the exact same linear speed. So my next step was to convert to find the angular speed of the rear gear. All I had to do was multiply by the size of the radius on the rear gear, and that's going to take my previous linear speed and convert it to an angular speed of the rear gear. Final answer over here to the right. Lastly, I know that same angular speed of the rear gear is conserved and then to the rear wheel, and so I can convert that angular speed into a linear speed of the the rear wheel by simply multiplying by the size of the radius of the rear wheel. And that sends me back to a linear speed. Final answer, 23,876.1 inches per minute. It's kind of a ridiculous measurement. That's a lot of inches every minute. Inches probably not the most appropriate unit. Which brings us to part B, convert that linear speed into miles per hour. So I took my previous answer in inches per minute, converted the inches into feet, converted the feet into miles, and then I chose to do my time conversion last, converted from minutes to hours. Final answer, 22.6 miles per hour. It's a pretty good speed for a bike.